Hey guys, and welcome back to another video on my YouTube channel. This video is all about solving past paper questions on topics related to trigonometry. I will solve one past paper question in each video, so please view the playlist to find more videos for more questions. So, let's get started. Here is question number 7 from the May-June paper for variant 3 in 2022. In this question, it says that the diagram shows a field AE-BC. As you can see on the diagram, we are already given the angle AE as 76 degrees and side AB as 82 meters and side AC as 55 meters. Part AE, as I'm showing you here, asks us to calculate BC. So we know that we have to find a missing side, and we have two sides given as well as the angle between them. Therefore, we use the cosine rule formula for missing side length to answer part AE of this question. I've already explained the topic cosine rule in my previous video. If you do not know this topic, then please refer to my video on the cosine rule. Moving back to the question, we just substitute the respective values into the formula here and get BC squared equals to 55 squared plus 82 squared minus 2 into 55 into 82 into the cosine of 76. Then we take the square root of both sides. Entering the square root of everything on the right side into our calculator and pressing the equals to button, we get a pretty long value, as shown here. So, we have to round it to 3 significant figures, which gives us our answer as 87.0 meters. Now, let's move on to Part B. Part B asks us to find angle AECB. As you can see, we have angle AECB, which we have to find, and the side opposite to it, which is 82 meters, as well as angle AE, which is 76 degrees, and the side opposite to it, BC, whose value we found in Part E. So since we have two pairs of angles with their opposite sides, we can use the sine rule formula for finding a missing angle to find the value of angle AECB. Alternatively, we can also use the cosine rule formula for finding a missing angle. This is because we have the value of the two sides in which the angle AECB is between, and we also have the side opposite to angle AECB. Therefore, we can substitute all that into the formula and solve for angle AEBC. However, I'm going to solve using the sine rule here. So, moving back to solving Part B of this question, first we substitute the respective values into the sine rule formula for finding a missing angle and get sine of angle AECB over 82 equals to sine of 76 over 86.9877, and so on. This is the value we found in Part AE, but we are using the longer version, not the rounded value, as the longer value will give us a more accurate answer. Also, I've already explained the topic sine rule in detail in a previous video, so if you need to understand it, please refer to my video on the sine rule. Coming back to our answer, then we multiply both sides by 82. Then, we take sine inverse of everything on the right side of the equation and enter all that in our calculator. Pressing the equals to button on the calculator gives us a pretty long value, so rounding it off to 3 significant figures gives us 66.2 degrees as our answer for Part B. Now to solve for Part C. Here, it says that a gate, G, lies on AB at the shortest distance from C. Calculate AG. Basically, the shortest distance from C to AB is the distance perpendicular to AB from C. So, drawing a line perpendicular to AB from C is where G is, as G lies on AB at the shortest distance from C. I've marked G on the diagram here. The line I drew perpendicular to AB, which is CG, represents the shortest distance from C to AB, as you can see here. Since AB and CG are perpendicular to each other, they are at right angles to each other. Therefore, the triangle ACG here is a right-angled triangle. Now, since we have to find AG, we can use SO CA TOA. I've already explained this concept in a previous video, so if you want to understand it, please refer to my video on trigonometry, SO CA TOA. Moving back to the question, we can see that we know the hypotenuse, and we need to find the adjacent. So we use CA. In other words, we use the cosine of theta equals to adjacent over hypotenuse. Substituting our values, we get the cosine of 76 equals to AG over 55. Then, we multiply both sides by 55. Entering the cosine of 76 multiplied by 55 into our calculator, we get a pretty long value. Rounding that long value to 3 significant figures gives us 13.3 meters as our value of AG. Now for the last part of the question, part D. It says a different triangular field PQR has the same area as ABC. PQ equals 90 meters and QR equals 60 meters. Work out the two possible values of angle PQR. Let's start by finding the area of triangle ABC. Since ABC is not a right-angled triangle, we use the area formula for a non-right-angled triangle, which is a half into A into B into the sine of C, where C is an angle and A and B are the sides between which angle C is. So, substituting our values into the formula, we get a half into 82 into 55 into the sine of 76. Entering all that into our calculator gives us a pretty long value. However, we do not need to round it off, as we will use the longer version of this value in our calculation further. Next, we apply the same formula to triangle QPR and substitute the respective values. This gives us 2,188.016863 equals to a half into 90 into 60 into the sine of angle PQR. Then we simplify a little and multiply a half into 90 into 60, which gives us 2,700. Next, we divide both sides by 2,700. Then, we take sine inverse of everything on the left side of the equation. Entering all that into our calculator and pressing the equals to button gives us one possible value for angle PQR. To find the other value, we will subtract this value from 180 degrees. This is because the sine of an angle can have two values, one for an acute angle and one for an obtuse angle. So, subtracting the acute angle value that we just got from 180 gives us 125.8672, and so on. So, rounding off our values, we get 54.1 as one of our values rounded off to 3 significant figures. However, we cannot round the other obtuse angle value to 3 significant figures as our final answer because it would be 126 degrees, and adding 126 and 54.1 exceeds 180. The sum of these two values must not exceed 180 degrees. Therefore, I will round it off to 1 decimal place as 125.9. So, the answers to part D are 54.1 degrees and 125.9 degrees. Thanks for watching. Please like and subscribe. If you have any doubts, please comment below and I'll answer them for you. You can find more videos on more past paper questions solved step by step on various topics in the playlist. I'll be back with another video soon.